Okay, hello everyone, and welcome back to today's presentation. So first thing I want to check, can you guys hear me? Just give me a thumbs up if you can hear me. Or in the chat window. I just want to make sure you guys can hear me. Anybody? Just want to make sure. Can you guys hear me? Anybody give me a, okay.
We can hear you. Thank you.
Great, thank you. Just want to make sure before I continue. Okay, so welcome back. Today again is the 6th week of our 8-week workshop and the Industrial Internet of Things. This workshop is sponsored by the UI Metal Casting and Foundry 4.0 centers. So during the presentation again, please mute your audio and ask questions in the chat window. You may turn on your microphone after presentation for questions. The video will be recorded and then sent to you once it is ready. Okay, so I don't think I need to introduce myself anymore, but again, the PowerPoint slides is available on this link, okay, on this link. So it has been uploaded for this week's presentation too. Okay, so this week, okay, is the 6th week, and then we were working on a project related to the publisher subscriber protocol MQTT, okay, implementation. Okay, we'll just discuss this one. Okay, so that's basically what we're going to discuss. Here's the outlines for today. And then we will basically have 2 parts, okay, in 2 parts. The first part is we're going to set up a Mosquito broker, okay? So the MQTT broker that we're going to use is the Mosquito broker, and then we'll make sure it is configured properly. That's the first part. Then in the second part, we will create 3 different MQTT clients. One is in that Raspberry Pi, another one, so that one is to publish the data from the BME280 sensor. Another one is on the Node MCU. It is also used to publish data from the BME280 sensor. Then a third one is a MQTT client set up in your computer, which is a subscriber. And then it's going to receive the message from the broker. Right, so that's the general 2 parts. Here's the system overview. We are going to implement it. So over here, we see this is a portion that we're going to implement. In the Raspberry Pi, we'll set up the broker and MQTT broker. At the same time, we connect one BME280 through the I2C to the Raspberry Pi. Okay, to the Raspberry, oh my gosh, Raspberry Pi. Okay, sorry. And then that's similar to what, it's the same connection what you did from last week. And then at the same time, we will have for a Node MCU board also connected through the I2C with another BME280. Okay, so they're going to connect and through the Wi-Fi, all connect to the same Wi-Fi. And I'm going to create another MQTT client on your local computer so that I can subscribe to the same topic, so I can receive the messages. For any message I received on this client, it's going to store the data in your computer. So that will be easier. So for example, if you use a Google Drive, then the data can just store in your Google Drive and then can upload it. Or if you use the Dropbox, whatever, it's going to store it in your computer. And then if that's the overview. Okay, that's the overview. Now let's look at what's the hardware we needed. So as we already mentioned, we're going to definitely need a Wi-Fi network, and you're going to have a Raspberry Pi connected to a BME280 board for my demo purpose, and another MCU connect to another BME board. Okay, so if you only have one, that's fine. You could just connect to one of them at a time, right? Test it out. It still works. And also another computer which are connected to the Wi-Fi, to a Windows computer. So the software we're going to use is previously covered. We, in additional to what we used in the week 5, also we need to use the Mosquito, okay? And one additional Python package we're going to use is a whole MQTT. This is the additional one which we need to install today. Again, the example project is available under this link. So just to go to that the PowerPoint slides. And then if you click this one, they will just lead you to the places where it is located. So like what you see over here, if I click this one, and then you should be able to see that's the example code we used for this week's project. Okay, so let's go back. So again, we already discussed the publish and subscribe model, but before we continue, I would go over it quickly again. So what we have over here, what we want to do is that the broker set up, the Mosquito broker set up in the Raspberry Pi over here is going to this broker is going to provide the service among different publisher and subscribers. So they are going to group the message based on the topics, and then the subscriber can subscribe on different based on that specific topics. We'll also have a look at those topics more later on. So the idea is the publisher, we will have 2 publishers in this example, right? Which one is that, one is the publisher under the Raspberry Pi itself, okay, to publish data whenever they read the data from the BME280. Another publisher is on that node MCU is going to publish data, again, read from the BME280. So there's 2 publishers. And I only have one subscriber, which is on your computer, which subscribe to the same topic through the broker, okay? So this is the overall ideas, the publish and subscribe model. So we use that MQTT, this message queuing telemetry transport protocol, which is based on those publisher subscriber model. Okay, based on this publisher subscribe model. So the good thing about this one, commonly used for the IoT, is really lightweighted. Though there's some disadvantages. When we look at code, I will explain a little bit more. So they need a broker, right? Broker in charge to group of the messages on different topics and then deliver them to the subscribers. So we use the different software available, but we use the Mosquito, okay, which we already introduced in the week 2, okay, introduced in the week 2. So make sure you check if your Mosquito broker service is running fine, okay? That means it's already installed. If not, just again, you want to download it and install it. Here we install not only that Mosquito, but also the Mosquito clients. Okay, that's just for test purpose. I would install both package, the Mosquito and the Mosquito clients. Okay. So what we want to set up the authentication is a little bit is that we would allow only the clients with the correct clients username and then password to be able to connect, okay? In this case, we could go through the process and create the file. The key thing over here is that once you created this password using this command and then setting whatever username and password. So you can change the username and then password depending on what username and then that you want to your Mosquito client to use. So those has to match, otherwise they cannot make the connection successfully. Okay, so I assumed that this file is under this, under this folder. Okay, under the slash etc/mosquito file or that directory, okay, under that directory. So that's a file, and with that information, you have to make sure and added several lines given over here in that Mosquito configuration file, okay? So how to edit it is just using nano again, but you do need a root. So we use the sudo, okay? So that you could have that a root privilege to write the Mosquito configuration file, okay? If you without the sudo, then it won't allow you to write or change the file. So there's 3 lines. The first line is allow anonymous false, meaning you have to make sure you have that provide the client username and then password to publish data or subscribe to the topic. Then second one is just define where is the password file. So this name could be, the file name doesn't have to be the PW file, just whatever file name that you used. Here is in this example, I just used the PW file, but you could use other names. And listener 1883, this is just a default port, open port that Mosquito broker is going to listening on this port, okay? And then this is without the TLS used, and that's a default port we're going to use. Just add this line into the Mosquito configuration file. So that will allow the user, not only the locally, but remotely, for example, your computer be able to access your Raspberry Pi. Okay, so by the way, before you do this, you need to, before you to modify this configuration file, you need to stop the service. So you're going to stop the Mosquito service, the broker. You want to stop the service first and then restart. Okay, once you restart the Mosquito service, then they're going to implement based on the updated configuration file. Okay. So then later on, you can test it if it works. If it works, in this example, we just showing, okay, the username. So for example, over here, we assume the username we set it is user1 and password is a workshop. And then topic I want to subscribe to it is -t, is the test, okay? So this is a client, which is a Mosquito client, subscribed to the topic test, okay? With the username, user1, with the password workshop, okay? So this is on the assumption we set up in the password file with this username and with this password, okay? If you're using different username and different password, yeah, you need matches what you entered over here to your own setup, the username and the password you just set up in the password file. Okay, so in this case, you see over here, mosquito underscore pop. This is another kind, just to test it out. You see again with the user name user1 with the password -p workshop, and then that the topic. Oh, I don't know. I think this is something messed up. It should be the topic, the test, -t test. You don't have to -t workshop, but -t test. So as long as it matches, and then you could follow by a message, whatever message you displayed over here. Once it is sent out successfully, it should appear in your workshop window. Okay, workshop window. So this is an example to make sure it actually works before we can continue. Now, if we want to test, so what we implement over here is just for the broker, right? Broker. We need a client to publish data and subscribe it. So what we want to implement for the next part is to implement MQTT clients. So there's 3 different kinds implemented, as I mentioned. We have 2 publishers. One is that in your Raspberry Pi, implemented in your Raspberry Pi using the Python, okay, using a Python code. The second one is that in the Node MCU, it's used Arduino IDE to do the programming and implement it pretty much in the C++ programming language. And then those are 2 publishers. And then we implement another subscriber, okay, another subscriber that's in a Windows computer, which I could basically subscribe to the same topic, and then going to receive the message, store the message to my computer, okay? So let's see the overall structure. What we're going to discuss for this second part, I'm going to discuss the step 1. So implement this whole MQTT client in your Raspberry Pi. There's a publisher first. So that's the first step. And I'm going to include the subscriber. Because if you only have a publisher and don't have the subscriber, you don't know if the data is delivered, right? So I'm going to implement a subscriber in your computer. That's step 2. And then the third one, I'm going to implement in another MCU. And with that, whatever this client received a message will not only including that published by your Raspberry Pi, but also by the Node MCU. Okay, so that's the 3 steps. No, that's the 3 steps. Now we talk about over here, and when we subscribe all the published messages, So has to be under a certain topics, So here we just talk about these topics a little bit. For the MQTT protocol, the topics are treated as a hierarchy, and they use slash as a separator. So for example, in this example, we'll just use a topic named like workshop BME 280. And then both the MCU and Raspberry Pi publish a message of that data detected or collected from the BME 280, which including your temperature, pressure, and humidity under this topic name. Okay, so when we subscribe it, you could also subscribe under this topic. And there's also have two wildcards are used. Those are useful. Okay, one is plus, and then one is a sharp sign. So for the plus, it's a wildcard for a single level of the hierarchy. Okay, for example, if you have a structure is organized as the sensors and the node ID and then types, the node ID is going to publish from which node. For example, my node MCU and then sensor 1, sensor 2, right? Different node ID, and then types could be temperature, pressure, and humidity, for example. Okay, different types. And then the sensor with that node ID is going to publish data based on the data type. Okay, if this data is organized this way, then a user subscribed to this one. For example, since node 5, for example, we assume there's a node ID as a node 5. There's a node named as node 5. Then if I do subscribe like this, then it's going to receive all the messages from the node 5. So it's really flexible and depending on how you want to use it. And if user subscribe to this, the plus sign is just for a single level hierarchy. So that means they're going to get all the temperature messages from all nodes, okay, from all nodes. So this is another thing. If we're going to use the sharp sign, this is a wildcard for all remaining level of the hierarchy. So in this case, I'm going to receive all the data from all sensors, okay, all the messages from all sensors. So it's pretty flexible. Make your subscriber what kind of message you want to subscribe to. Okay, that's wildcard. Now we will look at the first setup. Okay, so the first step. Now, what we want to do over here is we have to install the Pahot MQTT package first. So we'll just use PIP again. Use the pip to install the package. This is simply the Pahot MQTT is just a Python package that provided MQTT client class implementation already. So you don't have to write those from the scratch, right? You could just use that implemented MQTT client class and then make your implementation much simpler. Okay, so once you do this, download this code again. I only needed to code. This one is that MQTT pub BME 280, okay, which is going to call some functions under the save data py to basically save the data locally in the Raspberry Pi 2. Okay, so that's just 2 files needed. Once you download the file, test it. Again, you're already familiar with this command, right? Python followed by this example code. So once you've done that, the code should be showing like this, okay? So it's going to recording the data, whatever, you know, very similar to the last example, but I'm going to actually publish it through the mosquito broker, okay, or the MQTT server. Sometimes we also call it MQTT server. Then the file structure is slightly different. What we offer here is I just save the data under the folder or the hostname folder. I mean, it's no big deal, but anyway, it's going to store the data after the date the file or the message is received. Okay, after the message is received. Now, before we run this code, okay, before you run the example code, you need to change something. Okay, you need to change something over here. Depending on, so if you set up the username and the password, you change it in your broker, is not using this, you have to change it to the password and the username that you set up before. And now the ID depends on what you have. You know, usually you could just using your Raspberry Pi's host ID. And it's easier to identify if you have a multiple Raspberry Pi, right? You could name it. And they also have one parameter you can change. Here's the time interval. 10 in the example code we said is 10. That means I'm going to collect the data from a BME sensor every 10 seconds. So if you want to collect the data every 5 seconds or every 30 seconds, you can easily change this time. Now over here, this one, we call them MQTT server. Using this is a local host IP address 127.0.0.1 is a special IP address. It's used a local host. We can use in this case because my broker, mosquito broker, is also established. Is also set up on the same Raspberry Pi. So your Raspberry Pi, this MQTT client is running on the same host, okay? In the same host or the same Raspberry Pi that a mosquito broker is running. So that's why you could just using this one. If you want to actually see, for example, if you have multiple Raspberry Pi, and then set up a broker in one Raspberry Pi, I want to connect another Raspberry Pi, publish the data also to that the broker, which is in a different Raspberry Pi. In that case, this IP address should be the IP address where your mosquito broker is set up. Okay, just need to change it. So the code just gives you a little bit of explanation. And so over here, just like what we did in the before, just set up the BME object so you can use it and getting the data. Over here is you're going to just create the MQTT client object first, and then you connect it to the MQTT server, okay? So again, MQTT server needs to be an IP address of where your broker is set up. Okay, unless it is on your same Raspberry Pi, then you use this local host and IP address. Okay, while true, after this code, it is going to be, I'm going to just showing this one a little bit. Let's see. Sorry. I needed to with the, yeah, over here. You guys see my share screen. So is going to be this one. So if you look at this code over here, this is a while true. When it is true, what we want is I want to check if the time changes, okay, is greater than the time interval. If it is, then I'm going to read in the data from the BME 280s. Okay, we'll update those data, and then we will use the document, which is to save the data to a local file. Then we're going to publish the message. So over here, you can look at this line. Okay, look at this line. The client publish, and then topic. So the topic is what we're giving over here. That's workshop BME 280. You can select or use a different topic, but just make sure your publisher and the subscriber using a topic they understand with each other. Okay, so this is the topic, and then payload is whatever data we added the node ID. QoS. So the quality of the service, there's 3 different levels for MQTT messages. Here we will just using the 0, okay, which is by default is 0, meaning there's no quality controls, okay? And you could also use the QoS 1 or level 2, but they were going to increase the overhead, okay, increase the overhead because with a higher QoS, it requires a confirmation or acknowledgement of that message is actually delivered, okay, delivered. So this is pretty much the code. And let's see here. Okay, so now we can test it, use the Mosquito server, which is the Mosquito client that we already installed, okay? Because we haven't. So before you actually created the client in your computer, the subscriber client in your computer, you could use the Mosquito server, just this command to test if it worked. Okay, so in this case, over here, I will just again use the username. You see, -u user, -p is a password, and this is a -t, and then the topic is what? Workshop, and then /sign, that means anything related to the workshop going to be acquired data. So over here, I not only acquire data from the BME 280, in this example showing that I already also set up the node MCU1. So I actually got in 2 messages. Okay, one is from the BME 280, another one from the Raspberry Pi. Okay, in that local Raspberry Pi, but another one also from the node MCU1. So this is the case. And then if you want to test for example, in your computer, if it worked, you could also download the Mosquito client, which is available. Just click this link, and then you can download the file for the Windows. And then you're going to test it. Though again, in this case, the way how you're going to use the command is pretty much the same. But the key thing over here is that you have to make sure you have this command, okay? That -h. So that's a host or the server IP address followed by the broker IP address. So in this case, it will be your Raspberry Pi's IP address. You can use like hostname -i to obtain the IP address, which that you already did in several times. We did that in previous week. Okay, so this is how it works. So that's the first step of finish. The next one will do the second step. In other words, you're going to set up a MQTT client in your local computer. So how do you do this? Again, you need first use the pip to install the whole MQTT package in your computer first. So like this is pretty straightforward. And you can also click this link to see all the details about installation, okay? At external computer. Now, what we can over here, then you can download that file, go into this link. All the files are there. So if you go over here, then you can see there's have that MQTT sub, which is a subscriber kind for Windows, okay? And then you can just click this one over here, and that's a code, and then click this. See, that's a downloadable file. You can just click this one and then download to your computer, to your local computer. Okay. So once you download it, and then you can open the file using the Python. Here, I assume you already installed the Python. So for example, like for me, I could just open the file. Okay, I have downloaded this one, and then you could see edit with the okay, the idle, the Python idle. Once you open this one, several things you got to make sure to adjust is those things, okay? Topic, if you need to change, username and password. MQTT IP address. So this should be your IP address of your broker or your MQTT server. In this case, in our setup, should be the IP address of your Raspberry Pi, okay? Should be your Raspberry Pi. Once you complete it, and then you can, once you complete this one, you know, download and make sure it's a correct file, and you can run it, and then run the code. Once you run it, then any message you received is going to saved to a file named as this log, again, named after its date where I received the data, and under this home pass. So over here, which is going to be the cases, again, some of the configurations you need to over here. So I just assume that home path is this path. So I'm going to store the data under this folder. And if you don't want to store it under this, I mean, you definitely need to change because it's a different username, right? You want to change your home path to the place where you want to store your data, okay? Want to store your data. So this is another thing I want to mention. And then we will look at the example later. Here is just showing that MQTT, different from the previous one. There's two callback function is defined under this file. So the unconnected function is defined to subscribe a specific topic. So giving over here, the only new change on the top part of your code. Whenever the client is connected, they will subscribe to this topic. Like that's the callback function is going to do. And this callback function on message, meaning whenever I received a message from the broker, what should I do? So what we did is basically I'm going to save the data to my local file, okay, to a file in the computer. That's it. So this is the second part. Okay, second part of the client. And so the step 3, next part we'll look at is the node MCU. So again, in this case, my BMU280 need to connect to the node MCU through I2C interface, only for 4 wires, okay, the clock data and the ground and then the power supply, and which you can get that connection information in week 4, okay, in week 4. So we'll look at how does it work. Again, we'll use the Arduino IDE. And you're going to download the code. Download code, click this link. Okay. So over here is that, or if you go back to the weekly, then you can see over here is the BM280MQQ.INO. That is that for that any program worked with Arduino IDE. Okay, they use the .imo to identify it. So that's the file, and that's what you need. Also change a couple of things. Once you download the file, try to open it. As long as you already installed the Arduino IDE, it should open automatically. Okay, but it will always asking you to create a sketch folder for this .imo file. You just click yes. The system will automatically, create the folder, and then it's going to open the file. Okay. So once you open the file, several things you need to do. First is you have to click. They will actually, before we select this one, I already selected. So before you select, they will just tell you like select board, something like this, and then click this one, and then you will choose whatever serial port used, because you know the MCU is connected through the USB port to your computer. Okay, and then you're going to typically that driver, the USB driver, when you plug it in, they will first install the driver. And then once the driver is installed, you should be able to see the port under this selection, and then choose that correct port. And then you choose the node MCU, okay? And that way click, and then they will automatically configure all the proper parameters in order to download the program to it. So the next portion, oh, sorry, I forgot to click yeah, I'm talking about over here when we have to connect to the node MCU. And then you have to make sure I didn't realize it's still under the previous window. All right, so that's what you need to choose. Once you click OK, and then you're going to need to modify a few things. The first thing is the MCU need to connect to the Wi-Fi. You're going to need to set up your network name and also the password. Okay, and then also the MQTT server, which you need to change the IP address depending on what IP address of your MQTT server has. Okay, and the other thing is similar. So the MQTT username, password, modify according to your setup, and then topic, whatever topic you have, and then node 1, it depends on what you have. I think in my current example, I just using the node MCU 1. Okay, but see over here, that's the node MCU 1. Okay, and that's what you're going to see in the demo. Okay, but those can all be configured and based on your system. Okay, should be configured all based on your system. Once you finish the modification, save the file, click on the upload. It should upload to the system, and then you're going to need to click on that serial monitor. Okay, so you upload, click this link. Once it's running, click on this one. That's a serial monitor. It's going to open the serial monitor and you'll be able to see whatever the IP address you obtain and what's the data they are sending. So it's actually connected to the broker and then sending that temperature informations. Okay, so one of the same issue is that Node MCU board is it does not really have an operating system. So it does not really have they do not keep the time information, so there's no proper date and time. Over here, the time we say over here is just because I'm running the IDE in your computer, so that's a computer time. Okay, so just want to mention that. And if you want to run this code under the, so then you can check the data. I will show you that later on. And if you want to run the program on the background, okay, then again, you use the clone types to schedule the job on that. So you run the MQTT part by BME 280 in your Raspberry Pi. One thing I just want to mention is that you don't want to run the previous example in a project at the same time, because both are using the same BME 280. They're going to conflict with each other with I2C. Okay, so it's only at a time only running one program in a schedule one job on your clone tab. Otherwise, it may run into the issue. In your computer, you can also do the same thing. If in your computer, I want to run this subscriber, but I don't want to, open the idle window and then keep popping the message. I just want to run it on the background. You could simply just using the Python w.exe to running it. So for example, I'm showing over here, Python .exe. So I'm going to, running this MQTT sub underscore for windows.py, that's file. And you can see it's running. And then the file we're going to update it automatically. Okay, so the last thing I want to just show you quickly a few examples, see what's going on on my computer. Okay, so let's see. This is the window, which is in my PME 250. And then this one is actually running in my Node MCU. So you see over here, this data is going to update it, in a real time. This one is setting is every 10 seconds in that, in this sensor, in that Raspberry Pi. And in the Node MCU, you can see over here, I tried to update every 15 seconds. 15 seconds, okay? Now, if we look at, the, let's see, if we look at my local computer, yeah, so if I look at my folder, because remember I using that under the workshop. So it's actually under the user, document workshop. This under the directory, I saved the file. So now under this implementation, you can see over here, it is have the data updated. So that's sensor 216. And if I actually move this one over here, and you can see this is current, the newest one. So the file will automatically update it. And that's the Node MCU one is another file. And you can see over here all the way down, which is also has the information. The format you can adjust depending on which way you want to. So over here is the time which I received this message. Okay, and it's the time receives the message. So it's well updated automatically. And you can see I connected those onto the Google Drive. You see the small one. This is under the Google Drive, so they will just updating. You see the small blue one. That's actually receiving some new data. And then over here is this also thing. And then there's the time, 12:51, right? So that's pretty much for today's demo. And then any questions? Any questions? Yeah, that's just running. And then there's some of the links and the references. Do you guys have any questions? I know that today is a spring break and then giving this workshop from my home also. If not, I think we'll just stop over here. And let me know if you have any questions. Yeah, do try it out. And then example code is available in the GitHub. If not, I will just stop over here. And then if you have time, please fill out the surveys. And then especially if you can give me any feedback about the projects, that will be great. If not, I think that's it for today. Thank you. See you guys next week. We have only 2 weeks left.